Welcome back to my math YouTube channel. So I'm back with another example on finding the derivative of different functions. So guys, looking at this function, we can see that there's a ratio, there's a quotient, and then it's raised to the power 4. So just by looking at it, we can see that there probably is a combination of methods that one needs to use, because there's like a ratio, so which kind of suggests that we may have to use the quotient rule. And then this whole function is raised to the power 4. We can see that there's like a composition of functions going on here as well. So I think we have to here like either use the quotient rule first or the chain rule, or there could be a combination of other rules as well. So guys, obviously looking at this function and seeing that this whole thing is raised to the power 4, we can clearly see that the first thing that one should use here is like a power rule, but more like in terms of, and we can also think of that in terms of a chain rule, because it's not just one function raised to power n, it's like a composition of functions raised to the power n. So what we can do here is we can treat this whole thing as just a big X, and then it's raised to the power n. So guys, it would make sense for us to start with the chain rule first, and then we may have to use some other rules. We'll see once we start using the chain rule, then we'll see what other rules we may have to use. Obviously, one can see that there is a ratio, so we may have to use the quotient rule as we move on with the steps of writing the derivative of this function. So let us start by applying the chain rule, and then we'll see what else one needs to do. So the first step would be to kind of treat this as a big X. So if I treat this as a big X, it's X to the power n. What do? You just bring that n outside or up front, and then you have this whole function x squared minus 1 over x plus 4. Guys, as I have been trying to tell you, and that's how I will usually do it, that whatever is inside this parentheses, whether it's just in one term or it's a combination of terms or it's a ratio in this case, we just treat it as a big X, and then we just use the power rule as our first step. So we bring that 4 up front, then it's this term raised to the power n minus 1. So 4 minus 1 is going to be just 3. But then we cannot stop right here. We have to multiply by the derivative of the inner. So I'm just going to write that step. It's d over dx of the inner, and inner is, in this case, whatever is inside the parentheses, and which looks like a ratio of two functions, right? So guys, once we have this set up, then we can clearly see that this is already done. We already took care of that piece. Now all we have to do is we have to find the derivative of this function, which means we have to find the derivative of this quotient. And in order to find the derivative of the quotient, one has to use the quotient rule. So let us remind ourselves, what is the quotient rule? First of all, I'm going to identify this as my f function and this as my g function, because the quotient rule, the general form of the quotient rule, is represented in terms of f over g, where f denotes the numerator and g denotes the denominator. So in this case, the quotient rule when applied to for f over g is f prime times g minus g prime times f, and you have to divide by just the square of the denominator, which is in this case is g square, right? So that is my quotient rule if I have f as my numerator and g as my denominator. So let us go ahead and apply that. So y prime equals 4 times, guys, this I just have to rewrite it without really doing anything about it, cubes, and then let us apply. So I'm going to use a bigger bracket here, curly bracket here. Let us apply the quotient rule. So f prime, we have to find the derivative of the numerator, which is simply 2x, right? And then you have to multiply that by just the g function, x plus 4. That's pretty easy, right? Because the derivative of 2x, x squared is 2x, and derivative of this is 0, so we don't have to write that 0. Then, guys, I have to subtract. What do I have to subtract by? G prime. So g prime is the derivative of the denominator, and derivative of x plus 4 is simply 1, because derivative of x is 1 and derivative of 4 is 0. So I don't have to worry about writing that 0. And then I have to multiply this by just the f function, which is x squared minus 1. And then I got to divide this whole thing by the square of the denominator, which is x plus 4 whole square, right? So that is the quotient rule, or the derivative of this quotient, right? Guys, I think we can still simplify, and we should simplify this numerator and see what we get. So y prime is going to be 4. So we cannot leave it like this, because we can still simplify. So, and we should try to simplify as much as we can. And if we cannot simplify any further, then we're going to just stop right there. So let me try to simplify the numerator here. Let's see what we get. Guys, of course, we have to do the distribution, and then we'll see if we can combine any like terms and if we have any like terms. So 2x times x is 2x squared. Then I have 2x times 4 is 8x, then minus x squared. And then what else do I have? I have negative 1 times negative 1 is positive 1. I got to close that guy, and then I have to divide this whole thing by x plus 4 whole square, right? So when I simplify this further, I can already see that 2x squared minus x squared will be x squared, and then I cannot combine any other like terms. So finally it's going to look like this: 4 times x squared minus 1 over x plus 4 whole cubes, and then times, guys, I'm trying to squeeze this in here, so it's going to be x squared, and then plus 8x plus 1 over x plus 4 whole square. Guys, sometimes people like to combine these two and then you would just write it x plus 4 raised to the power 5, but you can even leave it like this. It's up to you if you want to even go further. But one thing that I can see here is that we cannot simplify this any further. This guy, again, I cannot really factor this or write the factors or simplify any further, so I think we can leave it like this. Guys, this is going to be the final answer for this particular example. So the key thing here was to kind of first decide whether we want to use the quotient rule first or we have to start with a chain rule. So guys, in this case, when you have something like this to some power, then first you want to start with the chain rule, and then once you write out, so I highly encourage everyone to write out the whole thing. Like here I have to write out, I did write out the d over dx of this inner function. Just from looking at this now, I can see that, hey, now I can use the chain rule. Sorry, not the chain rule, I mean the quotient rule. So I will use the quotient rule on this piece. We simplified as much as we could, and that was the final derivative for this function. So guys, this is example 4. I'm still going to show you a few more examples so that we get more confident and more comfortable with these type of chain rule. And again, you can see that it's not just one rule that we are using here. It's a combination of several rules. So I want you to be confident with using these different rules on one particular example. Okay, till then, guys, take care. I will see you next time.